Okay, today we're going over quadrilaterals and what the most specific name for each figure is based on our geometry terms of parallel, congruent, and perpendicular. So this is where we're looking at each one and stating out the proof of what it is based on which lines are parallel, congruent, or perpendicular. So our most basic form is a quadrilateral, and a quadrilateral is any shape with four sides. And so we look at these, whether it's labeled this way or this way, there's nothing there to show us that there are any parallel sides, and nothing to show us that there are congruent sides. So that is our most basic quadrilateral. If there's nothing parallel, nothing congruent, we just call it a quadrilateral. So now we have these little markings that let us know that these are parallel. And so we're just going to label and say, okay, AB is parallel to DC. And we know that because they've given us these little markings for parallel. And then the sides that have two letters is BC, right here, is parallel to AD. The other thing that can be used for parallelogram is that the sides are congruent. So we can also say, if we had the letters A, B, C, D here, our second proof could be that AB is congruent to DC and BC is congruent to AD. So if you have either of these, two sets of parallel sides or two sets of opposite congruent sides, that lets you know that it is a parallelogram. Alright, and then a rectangle is a type of parallelogram because we have the opposite congruent sides. And so we're going to start by labeling that as AB is congruent to DC. And because those both have the 12.8. Or if we're looking at this side, they both have the matching marks. And then BC is congruent to AD. Okay, so that lets us know it's a type of parallelogram. Rectangles also have the added 90-degree angles, so that's that perpendicular symbol. And so for that, we're just going to write AB is perpendicular to BC. BC is perpendicular to DC. And DC is perpendicular to AD. And so that's what lets us know that it is a rectangle, because we have both the opposite congruent sides and the perpendicular angles. Alright, a rhombus is another type of parallelogram because it has those opposite sides are equal and they're also parallel. So for rhombus, we see that all four sides are equal. So for rhombus, we're going to label that AB is congruent to BC, is congruent to CD, is congruent to AD. We should have our line segment symbol on top. So all we're doing is just labeling, hey, all four sides of those are the same. But because it's a type of a parallelogram, we also know that those opposite sides have to be parallel also. So we can also write AB is parallel to DC and BC is parallel to AD. And so that's what lets us know it's a rhombus. Anytime we have a parallelogram where all four sides are the same, but the angles are not the same, that's called a rhombus. So now we hit one of our most basic shapes. So the square. So square has all four sides the same, which also means those opposite sides are parallel. And so here we have MI is parallel to KL. IL is parallel to MK. And we know that because if the sides are the same, they're going to be parallel opposite to each other. And then we have all four sides equal each other. MI is congruent to IL, is congruent to LK, is congruent to MK. And they're all also perpendicular to each other. So MI is perpendicular to IL, which is perpendicular to LK, which is perpendicular to MK. So when we have a square, we have to say, okay, we have the parallel sides, we have everything equal, we have everything perpendicular. That's what makes it a square. Alright, in this next one, we have these two sides the same, and these two sides the same. Or if we're doing it with numbers, those two sides the same and those two sides the same. And so that is what makes a kite. For kite, there's no parallel sides. But we have the consecutive sides equal each other. So instead of opposite sides like we had for parallelograms, for kite, it's the consecutive sides equal each other. So this time, GT equals TA. And GO is congruent to OA. And so that is what makes a kite. That seems to be one that mixes people up a lot. But kite is when we have the two sides that equal, two sides that are touching equal each other. Next we have our trapezoid. So trapezoid, we have this one set of parallel lines opposite. So we have AK is parallel to LE in this one. This side is parallel to this side. And to differentiate it from a parallelogram, we're going to state that the other two sides, so LA, is not parallel. So not parallel means we take the two sides, make a parallel sign, cross it out. So LA is not parallel to KE. So to show that it's a trapezoid, you have to show one side parallel, one side not parallel. And then we're also going to differentiate it from the isosceles trapezoid. So isosceles trapezoid has two sides that equal each other, the non-parallel sides. This one, they do not equal each other, and so we're going to write that statement. LA is not congruent to KE. So it's not congruent. And so this is the proof for trapezoid. We have only one pair of parallel sides, the other pair is not parallel, and the sides don't equal each other. If it is an isosceles trapezoid, we start the same way. So AK is parallel to LE. I'm sorry, we're not on AK and LE anymore. This time it is WX. So WX is parallel to YZ. WY is not parallel to XZ. And this time WY does equal XZ. And so that's what makes it isosceles. If we have the two sides that equal each other, it's isosceles. So whether it's shown this way or shown with the matched numbers, that is isosceles. Right. All these properties of quadrilaterals are also drawn for you on page 9 of your packet. And so you can see parallelograms have those opposite sides parallel and congruent. We have diagonals bisect each other if we're dealing with diagonals, and we have opposite angles are congruent. So it's also listed out for us here if you like the word version of it. Rectangles are a type of parallelogram, and so that means the diagonals are congruent, and we have 4 right angles, and so that was the statements we wrote down. Squares have the 4 congruent sides, and so do rhombi. Squares are the join part of all the properties of rectangles and all the properties of the rhombi. And then kites are where we have the consecutive congruent sides. Kites are technically also a type of rhombi. And trapezoids have only 1 pair of parallel sides. So this gives you the diagram if you like it this way. If you like this type of diagram on page 10 of your packet, this gives it all listed out this way with the diagram up here. So those are there for your reference when you do this open note test at the end. So today's assignment is page 8B, where you're going to choose what's the most specific name and then write your evidence statements. And remember, evidence statements use parallel, congruent, or perpendicular. So every evidence statement should list the sides using letters and use your statement there.